The image of a bulky rocket engine with tons of intricate details was very familiar to us several years ago, but now it has gradually faded from our minds thanks to the advent of the most advanced rocket engine ever built, SpaceX's Raptor rocket engine. The Raptor version 3 that Elon Musk revealed recently looks so neat, separate from any rocket engine we've ever seen. Of course, to get there, SpaceX started here too. So how did Raptor go from looking like this to this in just a few years? Find out everything in today's episode. Raptor 3's upgrades while developing SpaceX's Raptor rocket engine. Elon Musk and his team faced several challenges. One of the main challenges was simplifying the complex features that other rocket engines had. They had to pioneer new technology, master a full-flow stage combustion cycle, and redesign all inherent components of the engine. This was a significant shift from the existing technology and required extensive research and development. Additionally, they had to ensure that the Raptor wasn't only simplified, but also possessed superior power. This required a high level of innovation and creativity, and now SpaceX has done the seemingly impossible. In August, SpaceX CEO Elon Musk stirred up the space community with a photo of Raptor 3 that looks so neat. This is in stark contrast to the Christmas tree look of the previous two versions, version 1 and 2. As Everyday Astronaut puts it, this is absolutely absurd engineering to simplify an engine down like this. What looks simple on the outside only makes for more complexity on the inside, so this must be a masterpiece indeed. To develop a simple system, the SpaceX team has spent a ton of time researching, developing, and testing state-of-the-art technologies that have not been done before. Elon Musk confirmed that in his tweet, the amount of work required to simplify the Raptor engine, internalize secondary flow paths, and add regenerative cooling for exposed components was staggering. The latest iteration of the Raptor engine, referred to as Raptor 3, has undergone extensive part consolidation. This means that many previously separate components have been integrated into fewer, more complex parts. Take, for example, in the transition from Raptor 1 to 2, engineers removed a large amount of plumbing and sensors. Many valves were combined into valve plates, helping further simplify plumbing. In the case of Raptor 3, the heat shield is a part that should be removed in the first place to save the potential mass. The next-gen Raptor engine needs no heat shield, right? However, the heat shield plays a vital role in managing the extreme thermal conditions experienced during launch and re-entry. So, how to remove it without damaging the engine itself? Elon Musk previously explained on X that if we can delete and integrate enough secondary structure small fiddly bits, then we can locally protect and rest and delete engine heat shields in detail. Everything is regeneratively cooled, he said. Elon Musk mentioned this during a part of Everyday Astronaut Starbase tour. Clearly, with the heat shield removed, the Raptor will be exposed, so it has to have cooling, and because it's exposed, it has to have cooling. So, this integral cooling circuits throughout all the parts, so it looks very simple on the outside, but it's complicated on the inside. Like even all throughout the preburner and the gas manifolds and everything, it's all that stuff you see stuck on the side disappears. Wow. And of course, the heat shield isn't the only part that's been removed. We also eliminate a whole bunch of bolted and welded joints. So, especially the bolted joints, you really want to get rid of those. Yeah, such simplification is aimed at reducing manufacturing complexity and improving reliability while maintaining or enhancing performance. So how do we simplify the structure while still increasing performance? You know, with 280 tons of thrust, V3's thrust-to-weight ratio is improved compared to previous versions. The key to this lies in the pressure inside the combustion chamber. Raptor 3 chamber wall might have the highest heat flux of anything ever made, Musk said. As the pressure within the combustion chamber rises, the propellants, fuel, and oxidizer are forced to combust more efficiently. This leads to a higher temperature and pressure, which enhances the energy released during combustion. According to Newton's third law of motion, for every action, there is an equal and opposite reaction. When the exhaust gases are expelled at high velocity, they create a reaction force that pushes the rocket in the opposite direction. This enhanced thrust enables rockets to carry heavier payloads, achieve higher velocities, and undertake more ambitious space missions. A higher chamber pressure leads to a greater thrust output, enabling a higher thrust-to-weight ratio. This ratio is crucial as it signifies the amount of force the engine can produce in relation to its own weight. A higher thrust-to-weight ratio empowers the rocket to carry heavier payloads or achieve enhanced acceleration, thereby expanding the range of missions it can undertake. Furthermore, the importance of chamber pressure extends to the design flexibility of rocket engines. Higher pressures offer engineers the ability to achieve desired performance characteristics while maintaining compact and lightweight engine designs. This flexibility is crucial in enabling the development of advanced launch vehicles like Starship, capable of fulfilling various mission requirements, including crewed missions, deep space exploration, and satellite deployments. Another secret behind Raptor 3 is internalizing secondary flow paths, which involves redesigning how propellants and gases move within the engine. This can lead to improved efficiency and performance by optimizing how fuel and oxidizer are mixed and burned. However, it also adds complexity to the design and manufacturing processes because precise engineering is required to ensure that these internal pathways function correctly under extreme conditions. In conclusion, part consolidation, weight reduction, and the ability to design complex internal structures are those that make Raptor 3 stand out from the crowd. However, it wouldn't be possible for SpaceX to bring that to reality without the support of 3D printing technologies, and fortunately, SpaceX is home to some of the world's most advanced 3D metal printing technology. A further comment from Steve Jurgenson, an early VC investor in SpaceX, suggests that the latest Raptor has been made possible with additive manufacturing. I'm sharing that additive manufacturing internally integrates so many formerly discrete components. Additive manufacturing, also known as 3D printing, is a computer-controlled process that creates three-dimensional objects by adding material in layers. It's used in many industries, including aerospace, automotive, and medical. While SpaceX hasn't provided any specifics about how it may have been used to optimize the Raptor's design or internalize some of those components, Musk appeared to confirm the use of them in a further comment responding, "Indeed, it is not widely understood that SpaceX has the most advanced 3D metal printing technology in the world. Additive manufacturing has several advantages over traditional manufacturing. First, it can create bespoke parts with complex geometries that are difficult to make with traditional methods. It generates less material waste and also reduces lead times. It allows users to customize, repair, or create unique objects. The rapid rate of development in new space applications has turned the sector into a major adopter of metal AM technologies. Ariane Group has been using metal for the production of heat exchangers for its Ariane 6 rocket launcher and components for communication satellites. Earlier this summer, Intuitive Machines Odyssey landed on the moon supported by a 3D printed component by Saki in the upper section of its engine nozzle. And back in March, Ursa Major successfully launched its Hadley engine, which can be built in a matter of days due to its reliance on the benefits of AM. Clearly, upgrading Raptor 3 offers many benefits, such as saving manufacturing time and expenditure. As you can see, the production of a Raptor 1 engine initially took SpaceX around 11 days, whereas for the optimized Raptor 2, that time was reduced to just 2 days and eventually to a remarkable 1 day per engine. This significant improvement underscores the advantages of simplification in design. For Raptor 3, production rates could potentially reach dozens of engines per day, a rate typically associated with manufacturing industries, not the rocket industry. This capability will be crucial to meeting future launch demands as SpaceX aims to build and fly vast numbers of Starships annually. Given the reduction of manufactured time, the cost per Raptor 2 engine has also dropped to an astonishingly low figure between $1 and $2 million. When scaled for mass production, this cost could decrease to as little as $200,000 per engine. The simplicity of the Raptor 3 also promises to drive costs down to unprecedented levels, though it's difficult to predict just how low these costs will go once mass production begins. Additionally, the simple design of Raptor 3 contributes to making Elon's goal come true, turning around the Super Heavy booster within an hour and launching the Starship daily. He has a point. The rocket engine's simple design reduces maintenance time between flights, thus also decreases the vehicle turnaround time.